Welcome back to our Python Quickstart tutorial. This video introduces you to matrix data types in Python. The data we are dealing with today, or the material, is collected in Chapter 2, Matrix Data Types in our Jupyter notebooks. I recommend to open those notebooks, go into the kernel, and use the restart and clear all output. For this will make it a bit more interactive, easier to work with that material. And if up here on the right, it does not show trusted, then please click on this and confirm that you trust the notebook or you won't be able to modify it and work with it. So let's look into the problem first. The main thing is we've done some data types. And if you look at those data types, they were lists, tuples, dictionaries, floats, booleans, etc. Well, nothing actually that looked like a vector. On the other end, why do we like MATLAB typically? Because for all the linear algebra, MATLAB, its strong side is it can deal with matrices. Yeah? The vectors, so la la. It represents them as n by 1 or 1 by n matrices, which is not always ideal. But nonetheless, we like it because that's where it's good. In Python, we need an extension, and I want to show you first why we need it. Let's start here and look at two variables. I have a and b, and things that look like a vector. Hey, 1, 2, 3, 4, 5, 6. These are 3D vectors if I look at this and think of it in MATLAB. But, and that's the main thing, there is a trap. What happens if I do a plus b or b plus a? This is not the vector operation. This is treating those lists as sets, and the plus operator combines sets. So it combines the lists. A plus B is the list 1, 2, 3, and the list 4, 5, 6 combined into one list. So that's the one thing. Then B plus A combines the list B with the list A. So we actually see that they are not even in the same sequence. So A plus B is no longer B plus A. That makes sense if we think of it as lists. If we think of it as sets, it makes no sense when we think of it as a vector. To make things worse, what are other operators, like the product operator? We may think, oh, that's matrix multiplication. No, for sets, the product is not even defined. It creates a type error and says, can't multiply sequences of type list. Yeah, so that's the problem. So the data type that looks like a vector does not behave like a vector. The solution to this is NumPy. NumPy is an extension package or module that provides two data types, or simplified two data types. One is array, the other is matrix. Both of them are data types that are similar to what you're familiar with from MATLAB. That is, you have now data types that can be 1D, 2D, ND matrices, or multi-index objects that we often call tensors. And the other thing, different from standard Python, arrays and matrices only make sense if every element in that object is of the same data type. So all integer, all floating point, all complex numbers, while the lists, they allowed us to say there could be an integer, floating point, a character, a string, and whatever in there. So careful about this. It's really much more what we are familiar with. So how do we use that? The start is a new command, and that should be typically at the start of your notebook or later of your program, of your file. And that says we want to import NumPy. Import NumPy means load whatever NumPy has to offer for us. This starts a new namespace, and since it's painful to always type numpy dot something, we use the extension SNP, which is basically an alias. We make a short form from now on. NumPy is called NP. Makes it a little bit easier to work with. So how do we create things? I want to create two matrices. I want to create a matrix that, let's quickly type that so we see what I'm trying to do here. Create an array that looks like this. That's my first. And I want to create those as an array and as a matrix object. So the syntax works. We create the actual matrix as a list of lists. The list works as the first line. So 1, 2 is our first line or the first row. The second row, and so forth. So what we actually represent a higher order object is a list of lists, and we build it row by row. Higher order object is a list of lists, and so forth. And then we convert this format into either an array object or into a matrix object by calling NumPy, and now in our short form, np.array, in parentheses. So you see the parentheses with that argument. The matrix works the same way. So as I execute that, I can look at this. If I just do the quick and dirty way, I type the variable a, it says it's an array like this. Or if I do print, it does a nice way showing me the matrix. Similar, if I do b, it shows me it's a matrix type, or if I do print, it shows it to me as a matrix. So the print command makes it look pretty, a little bit similar to MATLAB, but to make that a bit more clear, it still shows us it is an array of rows. So it's a list of rows, so it shows the structure a little bit better. So the first thing that we see here is print the array and print the matrix. Looks pretty much the same, and that's actually the case. They both try to represent the same matrix. But, and that's the big part, is the functionality. If you look at the functionality of these two, the matrix class is trying to emulate MATLAB or Octave if you use that as a very similar data type. And it behaves pretty much, if you have a MATLAB code, you want it to work in Python. The matrix class is the quick and dirty conversion. And you have the multiplication is the matrix product. But careful, transposition is not the prime. Python works with dot method. So you need to call, if you want to transpose of a matrix B, of a matrix B, you need to call it with the transpose method. So B.T gives you the transpose, and the inverse comes as B.I. That's an uppercase I gives the inverse. So how does it work with an array? The array has slightly different functionality, and it works where the normal product is an element by element multiplication. So that is like the MATLAB dot product, dot times operation, while the matrix product, or then later proper tensor operations, uses the at sign. So A at B is the tensor dot product. The nice thing is that the transpose and the inverse works the same way. So why do we want that? That looks at the first glimpse a bit crazy, but if you're dealing with anything that requires higher order tensors, so in mechanics, it's the material modelers. You may need a third order fabric tensor. You may need fourth order elasticity or any material tensor. Then these operations can fully implement dot product, tensor product, double dot product, while the matrix classes have limitations. And that's typically where MATLAB hits the limit for the material modelers. The other thing is if you do image analysis, that creates higher order objects. If you think of an image as a matrix of dots, but each dot now has a red channel, a green, and a blue, and then maybe an alpha channel. So there may be 4 layers of matrices. Immediately a 3D object, then the correct tensor operations can be more powerful. And for everybody who is new to the game, I highly recommend to start with array. I use matrix only for a quick and dirty conversion from MATLAB. So let's have a quick look. A is our matrix type. So A is our array. So if I do A times A, it is an element by element. So this is 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16. So this is not the tensor product, while on the other end, A with the @ sign is the tensor product that is really matrix times matrix. On the other end, B, if we look at B, is a matrix object. The matrix object, the multiplication sign is the matrix multiplication. So we see in the array object, that result is the same as matrix object using the product symbol. Gives the same output. That's not a big issue, but the important part here is depending on which object you use, you see that the functionality is different.